All right, one last example. If you feel like you're getting the hang of this, go ahead and just pause and try this one and then just check your answer. Otherwise, I will hop right in. So we want to find dy dx, which means we'll take the derivative of both sides with respect to x. And we have an x e to the negative xy. And then on the other side, derivative with respect to x of x squared over y. Okay, so on the left-hand side, what I see is a product. It's an x times e to the xy. So we will take e to the negative xy times the derivative of x, which is 1, dx dx is 1, plus x times the derivative of e to the negative xy. That is composite. I've plugged a negative xy into a basic exponential function. So I'll start with the outer function, which is exponential. The inner function is negative xy. The derivative of e to the stuff is e to the stuff. So that's the derivative of the outer. The derivative of the inner is actually another product rule. I have negative x times y. So I'll need y times the derivative of negative x, which is negative 1. And then I'll have plus negative x, so I'm just going to write minus x, times the derivative of y, which I don't know, so I'll just write in a dy dx. On the other side, I have a quotient, so I'm going to start with a y squared in the denominator. I will have a y times the derivative of x squared, which is 2x, minus an x squared times the derivative of y, which is a dy dx. On the top. Okay, so when I look at this, I actually see two problems. I have a dy dx stuck in parentheses and a dy dx stuck in a fraction. So you could tackle these things in either order. If you're really feeling brave, you could tackle them at the same time. I think I'll distribute first. So I'm going to clear the parentheses first. So I will have an e to the negative xy plus, minus an xy e to the negative xy, that's that first product, and then another minus, and that will be x squared e to the negative xy dy dx, and that's from that second product. I'm going to rearrange just a little, 2xy minus x squared dy dx over y squared on the right. Okay, so check, I have free dy dx from parentheses. Next, I'm going to free dy dx from this fraction. So I will multiply both sides by y squared. On the right, the y squareds just cancel. On the left, I need to make sure that I run that through the parentheses. I have 1, 2 subtractions, which splits it into 3 terms that each need to get multiplied. So I get a y squared e to the negative xy minus an xy cubed e to the negative xy minus an x squared y, I'm looking up above, y squared e to the negative xy dy dx. On the right hand side, I'm just left with the 2xy minus x squared dy dx. Okay, so I have successfully freed my dy dx's. The next problem that I would like to tackle is that they're on opposite sides. So I'm going to pick a side. I think I'm going to move them right again. It doesn't matter. It's totally fine to move either direction. The only reason I'm favoring right is because there's already 2 terms on the left that don't have dy dx's, so I'll get to leave them where they are. So I'm leaving y squared e to the negative xy minus xy cubed e to the negative xy. I would like to subtract 2xy from both sides because when I move all the dy dx is right, I want to move everything without a dy dx to the left. I have added the x squared y squared e to the negative xy dy dx. So I have x squared y squared e to the negative xy dy dx. And I have not moved the x squared dy dx. Okay, so I have collected my dy dx's on one side. I have moved every term that doesn't have a dy dx to the other side. we need to get down to a single dy dx, so we'll factor it out. X squared y squared e to the negative xy minus x squared. I haven't done anything to the left-hand side, so we'll just keep that as is. Okay, and then last step, if I want to solve for dy dx, I just need to divide by that stuff in the parentheses. So I'll have the left-hand side still exactly as it was, and then I will divide that by x squared y squared e to the negative xy minus x squared. And that is my answer. Again, you can check and see if there's anything you can factor out. It almost looks like it. I could factor y out of the top, but I can't factor a y out of the bottom. I can factor an x squared out of the bottom, but I can't factor it out of the top. And I can't factor e to the xy out of either, e to the negative xy. So I think I'm all set. I'd leave it right there, but always check for fractions and fractions, negative exponents. Ooh, I've got negative exponents. Man, I kind of don't want to follow my rule, but I said it's a rule, so let's fix it. That's not that hard to fix here. Basically, this means y squared over e to the positive xy, and this is minus xy cubed over e to the xy, and this is x squared y squared over e to the xy. So really what I need to do is multiply top and bottom by e to the positive xy. So what will happen is I distribute and it cancels. So I'm left with the y squared only for that first one. I distribute to the next chunk, and it's going to be a minus. The e to the xy's cancel, and I'll just have an xy cubed. And then I have a minus 2xy e to the xy. On the bottom, I distribute and it cancels the e to the xy. I'm left with x squared y squared. And then I distribute and nothing cancels, so I'm left with x squared e to the xy. Okay, so I didn't want to do it, but it's good algebra practice, and spotting that those negative exponents just mean fractions. That's always a good reminder as well. So that is my final answer. That is my dy dx. Okay, so hopefully that gives you some good reminders of how to deal with some messy algebra. I think I'll let you work on it from here. Thanks for watching.